Hello, welcome to week 17, chapter 12, lesson 1, finding limits using tables and graphs. This lesson is a foundation for the calculus class, which you are going to learn in the next year. So at the end of this lesson, you should be able to find the limit using graph and table, and also you should be able to find one-sided limit and use the concept of one-sided limit to determine the existence of limits. Now let's go to the content of the lesson. So in the content of the lesson, we are going to see the introduction part for the limit. Then we will see how to find the limit using tables and how to find the limits using graphs. Then we will introduce the one-sided limit and use the concept of one-sided limit to determine the existence of the limit. So at the end of each solved problem, you should be able to practice the question given from the textbook. Now let's go to the introduction to limits. In the introduction part, we are going to see the limit notation and its description. Suppose that f is a function defined on some open interval containing the number a. The function f may or may not be defined at a. The limit notation is given here, and the limit notation you can read as the limit of f of x as x approaches a equals the number L. This means that as x gets closer to a but remains unequal to a, the corresponding values of f of x gets closer to L. So the limit of f of x as x get closer to a is equal to L means just you will see or you will observe the nature of the function f of x as the x values get closer and closer to a, which is going to be L. So this is the limit notation and its description. Now we can go to practice of finding the limit using tables. So example 1, find the limit of 3x squared when x approaches to 4. Here you are asked what is the nature of 3x squared when x get closer and closer to 4. So in order to find this limit, what you need to do is you just prepare a table. Okay, so the table consists of the values of x's which are very close to 4 and the outcome when these x values are getting closer to 4. So just prepare the table. Okay, as x closer to 4 but unequal to 4, we must find the number that corresponding values of 3x squared gets closer to it. Therefore, we just see the nature of the function as x gets very closer to 4, like the point 3.99, 3.9999. So as you can see, the x values are very close to 4, but not equal to 4. So the value of 3x squared become very closer to 48. That means from the left and from the right. That means for x values which are less than 4 but very close to 4, and for other x values which are greater than 4 but very close to 4. And f of x, which is 3x squared, get closer to 48. Therefore, we can say that limit of 3x squared when x approaches to 4 become or equal to 48. So this is one way that we can find the limit using a table. Another example, finding the limit using tables. Find the limit of sine x over x when x approaches to 0. The same thing that we are going to use here. That means we will prepare a table which consists of x values which are very close to 0 but not equal to 0, and we will see the value of sine x over x. Okay, So as x closer to 0 but unequal to 0, we must find the number that corresponding values of sin x over x close to. Therefore, when you see the table for x values which are very close to 0, like negative 0.03, f of x, which is sin x over x, becomes 0.99985. And again, when you get closer to 0, which is negative 0.02, the value of f of x becomes 0.99993, and so forth. So, which means that f of x gets closer to 1. Therefore, you can say that the limit of sin x over x when x approaches to 0 is equal to 1. By the way, this is a very important limit, this limit of sin x over x when x get closer to 0, which is going to be, which is exactly equal to 1. We can use this limit to find another other trigonometric functions limit. Okay, this is very important, just keep in your mind. There is another way of finding this limit. You will see in calculus class. Now let's go to example 3, finding limits using graphs. Use a given graph to find each of the following. So the graph is given, the graph of f of x. So when you observe this graph, as you can see, the function f of x, it has open dots at x equal to 4 and at x equal to negative 2. F of 4 is 2 and f of negative 2 is 3. Then let's see the question. You are asked to find the limit of f of x when x approaches to 4 and the limit of 4 when x approaches to 4. So when you see the graph closely, for x values which are very close to 4, as you can see, f of x get closer and closer to 7. That means you will see x values which are less than 4 but very close to 4. So the function is getting closer and closer to 7. And for x values which are greater than 4 but closer to 4, again the function f of x get closer to 7. Therefore you will say as x get closer to 4, f of x get closer to 7. Therefore the limit of f of x when x get closer to 4 or approach to 4 is 7. The second one, the limit of 4 when x approach to 4. Here f of x, the graph, the curve, which means it is not continuous at 4. Okay, there is open dot, but there is a closed dot at x equal to 4 will become 2. Therefore you can say that at x equal to 4 the open dot does not include in f of x. The graph f at x equal to 4 is shown by the closed dot at 4 2. This means that the limit of 4 when x approaches 4 is or equal to 2. So this is example 3, finding limits using graphs. Let's go to example 4, find the limit by graphing the function. Okay, graph f of x equal to 2x minus 4 for x different from 3 and negative 5 when x is equal to 3. Then find the limit of f of x when x approaches to 3. So here we have a piecewise function. That means the function is defined by two equations. Therefore, we need to draw the graph of 2x minus 4 using the x and y intercept, and you will make an open dot at x equal to 3 on the curve. Then at x equal to 3 you will have a closed dot at x equal to negative 5. So when you sketch the graph, it will be like this. And if you have the graph, then it will be easy for you to find the limit. So when you see this graph, for x values which are very close to 3 but less than 3, the f of x has become closer and closer to 2. And the same for x greater than 3 but very close to 3, the same thing will happen. That means f of x get approached to 2. Therefore, you can say that limit of f of x when x approach to 3 is 2. So example 4 is about graphing and finding the limits. Now the next thing is about the concept one-sided limit. One-sided limit means I tried to mention this thing is that means when x get closer to a from the left and closer to right from the right, which means that you will take x values which are less than a, and you are going to get or you are going to take x values which are greater than but closer to a. So we are going to have left hand limit. The limit notation is given here, so you can read this one as the limit of f of x as x approach to a from the left equals L, and it's called the left-handed limit. So in the left-handed limit, you will take for x values which are less than a. Okay, and for the right-hand limit, the limitation is given. The limit notation is given, and this will be read as the limit of f of x as x approach a from the right equals L, and it's called the right hand limit. This means that as x get closer to a but remains greater than a, the corresponding values of f of x get closer to L. So this is a one-sided limit. By the way, the one-sided limit, it will help you to determine the existence of the limit. Uh, when we'll say that the limit exists, when the left hand limit and the right hand limit become equal, then you will say that the limit exists. Otherwise, the limit, it will not be exist. That means if the values of the left hand limit and the right hand limit, if it's different, then the limit doesn't exist. Now let's go to problem 5. Finding one-sided limit using a graph. So the graph is given, I think. Yes, the graph is given here, and you are asked to find the following limits, and also you are asked to find f of negative 2. So in part A, you are asked to find the limit of f of x when x approaches to 2 from the left. That means the left-handed limit. So the graph, you just see the graph, and when x approach to 2 from sorry, negative 2, not 2 here. When x approach to negative 2 from the left, it become getting closer to 0. And let's find f of x when x approach to negative 2 from the right. When it gets closer to negative 2 from the right, the value is getting closer to negative 2. So here 0 and negative 2, they are not equal, which means that the left-hand limit and the right-hand limit are different. Therefore, the limit of f of x as x approaches to negative 2 doesn't exist. Therefore, it will be undefined. And finally, f of negative 2. So f of negative 2 is there is a closed dot, as you can see, a blue closed dot, which is at exactly negative 1. Therefore, f of negative 2 is equal to negative 1. So this is all about the introduction part for the limit. As I said earlier, this lesson is important for the next year lesson about which is about calculus. We will have more examples regarding limit, and I will try to include the properties of limit in the live discussion. But for now, I will stop here. Thank you and goodbye.